In this lecture video, I'm going to teach you how to plot the graph of inverse functions using parametric equations. But first of all, the key question here is, what are parametric equations? At the same time, how are parametric equations being dealt with in terms of your grapher? Now remember, your grapher has a parametric mode in it. And all you have to do is to click on that Y menu, and I will show you how to do it later on. In this presentation, we will have a discussion of an example of parametric equations, and we're going to plot a given parametric equation also. But of course, this is in reference to your grapher. I'm not actually going to show you the demonstration of the grapher, because this application doesn't have the, what I call this, it doesn't have the tools for the grapher yet. Anyway, parametric equations are equations wherein x and y are expressed in a third variable, which is usually t. It's usually t, right? Now, we have seen all of the equations. For example, we have y is equal to x plus 5, y is equal to 2x squared minus 4, y is equal to x plus 1 over x minus 2, and so on and so forth. Now, all we knew and all we have seen are equations with two variables, x and y only, or if it's not x and y, it's another variable. It could be any variable, but not with a third variable t. And this is where parametric equations come in. So parametric equations are equations with t variable as the third variable. And so I'm going to give you an example of a parametric equation. So we have x of 1 of t. Let's say that's equal to the absolute value of t minus 2. And the x or y 1 of t, because as I have told you, our x and y coordinates are not expressed in a third variable t. And let's say our y1 of t is equal to the square root of t plus 2. So on this example, or in this example, we are required to plot the graph of these parametric equations. These parametric equations, x1 of t and y1 of t, by first calculating the values of x and y for integer values from 3 through 7. So we have a given interval here from 3 to or from negative 3 to 7 for the t. Okay? So this is our this is actually our table here. Just that you couldn't see the t here. It should be t here. This is x. The middle one is x, and the third one is y. Now let's solve for x and y when t is of a certain value. If t is equal to negative 3, for instance, then we are going to substitute our negative 3 to the t here. And that means that our x1 of negative 3 would then be equal to the absolute value of negative 3 minus 2. That's equal to the absolute value of negative 5. That's equal to 5. Why? Because remember, absolute values are always positive, even though the input or the inside value is negative. The output is always positive. And that's one property of an absolute value. So let's put 5 here on the x column. So we have 5 here. How about the y? Now let's take a look at our y. So y1 of -3 again for t. These are our t values. This is when t is equal to -3. And the same is true with y1 where t is -3 also. So we have square root of -3 plus 2. And that will just give you square root of -1. And square root of a -1 is an imaginary number. I, or yeah, it's an I, right? Because remember, -1 is equal to I squared. So the square root of -1 is equal to square root of I squared also. And that gives you I, which is imaginary, and therefore in calculators such as a grapher, wherein the imaginary numbers are not recognized, in such cases when imaginary numbers are not recognized, then we simply have to put the value of y as none. Okay, there is no value for y. So going through all of the values for t for x and y, or x1 of t and y1 of t rather, we will get these values. So this one is 4. X is 4 when t is equal to -2. Now you can try that with a pen and paper, okay, or your calculator. Okay, we have if it's 0, it's 2. If it's 1, it's also 1. If it's 2, it's 0. If it's 3, it's 1. If it's 4, it's 2. If it's 5, it's 3. X is 3. And x is 4 when t is 6. And x is 5 when t is 7. Now for y values, if our t is -2, then that's 0. That's obvious. If -2 for t, that will have -2 plus 2, that's 0. And then for -1, it's 1. For 2, it's 1.41. For 2, for 1, it's 1.7320. I'm just approximating the values at the what do you call this? The 10,000th place value for the decimals. Okay, at t is equal to 2, then our y is also equal to 2. If our t is equal to 3, our y is 2.2360. This will be 2.4494. You could always check that using a calculator, okay, or a pen and paper if you are very hard working. Okay, this is 2.8284, and this is 3. Now, how do we graph this? Of course, it's not if in a Cartesian coordinate wherein there are or in a Cartesian coordinate system where there are just 2 dimensions, and you can just get or plot. So if this is your Cartesian coordinate system, we only have the x and y axis. Okay, you have the y axis and the x axis. But we require a certain t in a 2D coordinate system like our xy system. We cannot just simply put t in there. I mean, t does not appear in the Cartesian coordinate system. So what we use is a specific grapher, which is found on your calculator. Now on your calculator, these are the things that you need to do. Number one, of course, you have to set your grapher into parametric mode. So set your grapher, set grapher in parametric mode. Now, your grapher is allowed to perform these operations in parametric mode. Okay, parametric graphic, or graphing of parametric equations to be exact. So set your grapher in parametric mode. Okay. And then number 2, is, you can see a Y menu in there. So on the Y menu, enter these values or these terms. Okay. x1 of t is equal to absolute value. We have ABS, stands for absolute value or absolute. So ABS of t minus t. Something wrong with the pen. T minus 2. Why isn't it clear? Okay. So t minus 2. Now set your y1 of t into square root of t plus 2, meaning that it's the positive square root, not the negative square root. Okay? And then after that, so step number 3, use a window. With we have here in the requirement, we have from t equals to negative 3 through 7. So because your grapher has the property or the characteristic to perform a given interval for t, for graphing x1 of t or parametric equations, x of t and y of t, then we have to set the window with certain intervals for t. In this case, we have the interval negative 3 to 7, and also set your x window, okay, to the intervals 0 to 5, and also your y. So also your y. So from 0 to 5 also. Of course, that doesn't end there. The third thing is we have to use, the last is use a t-step. What do you mean by t-step? It's like, this tear for t is like unit scales for t. Okay, so we say our t-step is as comfortable as 0.1. So we set our t-step at 0.1, and I think that's the usual thing. Okay, we put the t-step at a convenient, because it's convenient, so we put it at 0.1. So what happens? So what happens is then this will be our graph in parametric mode. And as you can see, this is not complete because we only have our linear, what do you call this? The line here from 2 to 5, or from 2 to 3 on the y-axis, and from 0 to 5 on the x-axis. So let's highlight that thing. This is from 0 to 5. Okay, 0 to 5. Okay, and we also have something here. The points are plotted on this portion, and we want to graph to connect all of the points there, and it will give us a better view of another curve, which is our we have this curve now. So, but I'm not satisfied with the way I did it. So let's do another thing, like a yellow drawing. Then we have, okay, those dots. Remember, they should be perfectly connected. So they should be perfectly connected. Okay, so we have this one. Make this yellow. Okay, those are the points. What are those points anyway? So this is our t is equal to 2. The parametric mode of your calculator and the graph of it, it will show that this is t is equal to 2. And also this is our t is equal to 2. This is our t is equal to 1. And remember, we have our graph here. So at t is equal to 1, we have our x is equal to 1 and our y 1.7320. So this will be our t is equal to 7. This is t is equal to 3, 4, 5, and 6. And your grapher is programmed to show you this graph. So you try it, okay, by following the certain steps given here. And you will surely get the same graph as I did. And limit your window, okay? Your window for x should be from a certain 0 to 5, because you can see the domain here, it's from 0 to 5. So it's from 0 to 5 here. You could see the x values. And your y values, you could set it also from 0 to 5. Also, you can see that the range here is closer to 3. But anyway, we could make it symmetric with our x values. So we set our x values from 0 to 5, as well as our y values from 0 to 5. So that's it. That's our plotting of parametric equations using your grapher calculator. Let's have an example. In this example, we are required to plot the graph of y is equal to 0.5 x squared plus 2 for x in the domain of x from -2 to 4, and its inverse using parametric equations. Okay? Now don't be confused with the term inverse function with an inverse. Okay? An inverse, a certain given function such as this one, okay, is a quadratic function, and this is not invertible. But we could still get the inverse of this one. But that inverse is not a function. That is an inverse relation. So not to be confused with an f having an inverse of f negative 1. What we're trying to prove with the latter part, if f has an inverse f negative 1, then it's 1 to 1. In this case, if in the case of the quadratic function 0.5 x squared plus 2, well, this is a function, okay? But its inverse is not a function, it's a relation, okay? Therefore, this is not invertible, okay? Meaning that it's not 1 to 1, it's just a relation, okay? And why? Because you know, if we flip, as I've told you a while ago, the original is like that, and if it's actually not like that. It should be on the vertex should lie in this example on the origin. Okay, let's draw a better one. Okay, if it's like that, and this is the original. And this is the inverse. Okay? And we can see that they are, you know, mirrors of each other in the line y is equal to x. We could still get an inverse for this one by getting the inverse, which is this one. Okay? This is y2, this is y1. but this is not one-to-one, which fails the invertibility property for functions, because what we got here is a relation, whereas the original is a function and we get a relation. But if it's a one-to-one, then in the case of linear functions, if it's our y is equal to x, okay, and if this is our linear function, then you can see that, you know, the inverse is still a function because it's strictly increasing or decreasing, and it's also one-to-one. So that's what we are trying to prove about a function having an inverse function and a function having an inverse relation. So I hope that clarifies the confusion, if there's any. Okay, so let's try to clear the annotations here. Okay, we are going to plot the graph of y is equal to 0.5x squared plus 2 for x in the domain -2 to 4. -2 to 4, and it's inverse using parametric equations. So what do we do here? Certainly, we need a grapher. Okay, and your grapher has a programming for parametric equations. First, set the calculator in parametric mode. Parametric mode. There you go. Parametric mode. Okay. And then in parametric mode, there is a Y menu. On the Y menu, okay, enter this setup. Enter x1 is equal to, or x1 of t for parametric mode, and therefore our y1 of t will be equal to 0.5 t squared plus 2. Why did we set x1 of t as t? Because as you can see, if x is equal to t, then y is equal to the original function, which is 0.5 x squared plus 2. This one. Is that right? So this one is just something that is, what do you call this? It's like a shadow for 0.5 t squared plus 2. Now this is setting the y menu on parametric mode for our function of x. Now suppose the inverse would be f negative 1 of x, then we would have to set the parametric mode for x2 t, which is equal to 0.5 t squared plus 2, and our y2 t is equal to t. What did we do here? What did we do here? Remember that inverses have interchanged range and domain, and therefore we have to interchange the equations for x and y. Okay? So what we did here is we interchanged equations for x and y. So how did we interchange that? Our x1 of t here becomes y of 2 of t is equal to t on this side, and our y1 of t 0.5 t squared plus 2 now becomes x of t 0.5 t squared plus 2. And step 3, we're not yet finished. Our step 3 is to set a window or use a window with the interval of t from -2 to 4. Okay, so -2 t 4 And you could use an interval for x, which is from 0 to 5, if you may like. So let us have x from 0 to 5. And another one, our y, from 0 to 5. Or it could be what do you call this? It could be more than 5. Okay, and use a convenient step, t-step. Our convenient t-step would be at 0.1. Now I've laid down the points for the graph. So all you need to do is to trace the graph using some convenient colors. So we'll do with this one. So by tracing the graph, okay, so perfect. So this one and this one, and I will trace the other one with a red color. Oops, okay, this one. This is perfect. Okay, so as you can see in the graph here, they are a reflection. So our first one is equal to 0.5 x squared. Okay, y is equal to this one here. It's equal to our f of x, which is equal to 0.5 x squared plus 2. And the other graph here is just our f negative 1 of x, which is equal to 0.5 y squared plus 2. And we could see they are just mirror of each other. And we could see that the domains here, okay, we have the domains. Our domain here for the first graph is from negative to, for example, in this part, okay, on this part, this to this. Let us take this example, okay, for the domain. Now the domain here becomes the range here. It becomes the range for this other function here. So here. So therefore, the domain of the original function, f of x, becomes the range of the f negative 1 of x. And the range of our f of x becomes the domain of our f negative 1 of x, just confirming that they are reflections of each other. So that's how we solve it. That's how we solve example number 2 using our parametric equation or parametric grapher. Okay? So thank you for watching.